as a component of the machine learning capabilities and our ability to look at multiple data sets or what we call data layers, which I'll explain to you shortly. Uh, we have done some work with organizations that have focused on making their fleets more safe for their drivers and for their customers and for their movements. And this is an example of one of those dashboards that was created for an organization in Mexico, where what we did here was we looked at where the assets were going on any given day, any given time, projected their routes from origin to destination. And as you can see, some of these routes are rather long. So these routes span over multiple types of weather systems. And what we're able to execute here is understand where that truck is going to be at any given time and what that weather system looks like when that truck reaches that location, enabling a text message to the driver for warning them of the potential challenge in the weather or other data sets, which we'll talk about here shortly. And also then providing them with a potential alternate route around that if at all possible. So the idea behind this is to be preventative, to minimize the risk and therefore minimize your safety events. And next slide there, Dan, if we could. And that's the theme of where we're going today, folks, is, when you identify an issue like safety, safety is an umbrella issue, but what it allows us to do and what we see as being very important in the understanding of safety is not just what the behavior of the driver is, but also what is driving that behavior. And so one of the advantages you have when you look at things from a location and a location perspective is to be able to understand how things interact with other assets around or where they're going or other components like that. So obviously, when we're moving assets, we want to avoid a certain amount of types of things. So for example, record breaking snows, you don't want your driver to go through that. You want to be able to look to see where there are potential snow drifts, and snow drifts happen with wind and excessive snow, whiteout conditions, wind. These are combinations of data sets that are coming into our system. And what this allows us to do is focus on that problem of, okay, I have to get my driver from point A to point B. What is going to happen to that driver, potentially happen to that driver, and let me get them out of harm's way. And then we also look at things like man-made or other types of natural disasters. Man-made for this case would be construction projects or road closures or excess traffic, where natural disasters, in addition to weather, would be things like the fires that we saw in Southern California, and how those fires may affect not just the cleanup effort or the current effort, but the cleanup effort moving forward, the interstates that are going to be applied to the movement of those goods and whatnot. So when we look at safety, what we do as a team is we look at not just safety, but we look at what the elements that are driving those risks and how we can minimize those elements moving forward. Next slide there, Dan.
Yeah, and the layers that Brian's mentioning are really just a sampling of what our capabilities are. We talked about fire, we talked about there's traffic, there's weather, there's wind, but we actually have access to 7,000 data layers for geopolitical risks and things like what are the theft patterns within certain areas of the country. So there's a lot more information and analytics that can go into these dashboards than just the 4 or 5 that we're talking about.
And a lot of that a lot of telematics systems can send information that you see in front of you, things along the lines of a distracted driver or speeding event or potential crash or harsh braking event. And these are all things that are done through the GPS. And this is something that we do spend a good amount of time on researching and understanding. And specifically when we look at driver safety, the first thing there is distracted driving. This morning, a colleague of mine had a conversation with one of our customers where he said to us, when it comes to distracted driving, we're not 100% sure what's driving distracted driving, because we see the driver picking up the phone, but the driver claims that we're texting them. So what are the things that you can do to actually understand that in more detail, right? And when you look at holistically in a platform such as ESP that looks at how to combine data across the ways. One of the things that we could look at is when the text message was sent by the dispatcher, when it was received by the driver, and when the distracted notice takes place. By combining those 2 or 3 systems together, our system enables you to understand, is that distracted driving actually a cause of a dispatch, or is that distracted driving a cause of something more personal? And if it is a cause of a dispatch, then how do we resolve that issue, right? Are there things that we can do in the cab? So my point in telling you this is that when we look at these scenarios are much larger than what is perceived as a stovepipe. And what our advantage here is, when we look at things across the board, we can start to plug these components together to really understand what is in fact causing distracted driving, what is in fact that crash, what is in fact driver fatigue. And so these are common causes of truck accidents. The capabilities that you kind of have in your back pocket right now, most of them have some type of in-truck capability. If it's an EDI or a GPS or some sort of in-truck capability that enables information to come back. Some are more advanced, where you have video capability within the cabin looking outward. Those are all very important components, but yet just one piece. That connectivity back to a central repository where you can see where those assets are and what they're doing is important. But connectivity with other business systems like your dispatching or your TMS or your warehouse management, or as we provide, those data enrichment layers. And these are those informations like the weather information or the geopolitical information, right? And then again, what we do is we use a concept called data layering. What we do is we look at that data as it is sitting on Earth. So for example, if I have my base street network here, I can overlay telematics onto it here. I can overlay live traffic onto it here. I can overlay weather onto it here. And the way our system looks is we actually can go down through the center of all that to understand how one thing interacts with everything around it. And that's where our data analytics comes into play. We use modern data analytics like any other organization would, except we add the location to it. And what that does for that is that adds an advantage to our ability to provide alerting and additional actions to what what our customers need through their operations. This is an example of the data layering. On the right-hand side, you see some different data sets that are available that you have access to, things like earthquake information, weather information. And when we say weather information, we use that in a vague term. You can see radar, you can see snow, you can see wind, you can see rain, you can see those types of things. You can also see forecasted data. Road conditions, another generic term. We can look at things like real-time traffic. We can look at where construction projects are. We can also analyze your fleet to understand where they're finding issues in their movements on a more regular basis. So if we can identify if there's a particular intersection, or if there's a particular yard or port or freeway that you're driving on that tends to cause more issues. And then what you see on the left-hand side is kind of a combination of that with one of our customers, where we're looking at things like their turn times at a terminal. How long does it take me to get in and out of that terminal?
So moving from safety to productivity, this is the Port of LA, and we're able to provide a dashboard in real time for the queue times into the terminals and then the in-terminal time. And what we look for in this is to hand this over to the members and allow their dispatchers to enable them to make decisions. If they see something that's an hour and a half lineup to get in a terminal, APM or one of the others, against a 15-minute, and to the extent that they can get an appointment, to the extent that they have optionality to pick up containers at different locations, that could make them more productive and increase turns, paid turns per 8-hour shift per driver. One of the other things we can do is create dynamic queues, right? The queue length will vary based upon how much trucks are getting into the line. And sometimes we know that can back up to the 110 or the 710 freeway.
We have a question from Jody.
Okay.
So she says, how do the layers speak to one another? What does the output look like?
So these layers are location-based layers, and the way we use them is that we can look at a location and compare all of those layers to that location. So an address, for example, or a terminal, or Dan mentioned the queue. We can actually look at those specific, points or areas or roadways, linear features, and compare those to other things that are in that location or going to be in that location. And that's how the layers kind of speak to one another. And then what does the output look like? The output is really a business decision. We've shown some outputs. This is an example of a dashboard that is using this location-based concept to aggregate data up and predict data forward. Some of our outputs are text messages. Some of our outputs are reports like you would see, PDF reports, Excel reports. Really, it comes down to what the customer wants to see and how the customer is going to interact. What we try to do and what we focus on is providing answers and actions. So a lot of our outputs tend to drive a user into doing something. So a text message alert, or like Dan said, this looks at the terminals and what's going on in those terminals, and then what's going to be going on in those terminals, which gives them the ability to create an action based on the information that we're providing. Hope that answered your question.
So in real time, right, showing you the analytics and showing you the ability to give a dispatcher options, and we know that they're revamping the appointment systems in these two port complexes. But then think about, the data layers give you the context of some of those environments they're moving through. But on top of that, the machine learning leading to AI, the ability to take millions of data points of the ins and outs of these terminals, and then being able to look forward and say, this is what we think is going to happen rest of day, tomorrow, next week, next month, and then certain months of the year based on seasonal patterns that we've seen and identified through the history of data we've collected, right? And that's why it's important for us to collect that data to be able to run those analytics and then help to drive productivity, not only in the moment and making decisions in real time, but also as that dispatcher plans the next day or the next week. So again, productivity, the ability to pair certain locations with drop-offs and pickups to make you more efficient, the consideration of traffic and times of day that they're being dispatched into. All of that information is able to be analyzed together under what we call a geospatial, a location-based approach, to give you the best options to be productive in the movement of your assets. Brian mentioned before the construction activities, Caltrans, any kind of earthquakes, any kind of wind advisories that might cause issues, and ultimately the ability to take that information and communicate it. Because it's great to have it, but if you can't communicate it to the people that need to know before it happens, the driver, the dispatcher, anybody else in the organization that's operationally oriented, then you're not going to be able to react to it and avoid the issues that are coming up. One last area, there's also an opportunity to apply security technology as it comes to theft or damage of goods. And we've all seen the statistics, 72% increase in theft in California. Rail cars, 160% up. Travelers Insurance issued a report and said full container theft is up 1,800%. And what they're suggesting is people are picking up from load boards, and they're not authorized truckers to take that container, and they pull the whole container out and steal the goods. And the interesting part is that it's viewed from a crime perspective as very low risk and very high reward. And it probably speaks to the fact that these containers and rail cars are generally available for people to be able to pick up. And how do you then secure them and make sure that doesn't happen? The concentration, makes sense given all the volume coming through the Port of LA and Long Beach, that the concentration of theft is highest within 70 miles of those ports. 71% of the thefts for cargo are happening in that circle. And so how do you deal with some of that? Some of that in combination to what we do along with smart container technology, right? We know there's roughly 65 million containers in the world, and less than 4% are smart. We know that Hapag-Lloyd is looking to censor up and spending about $200 million to make their containers smart. And what it'll enable is an ecosystem of data sharing and traceability, visibility into where those containers are. But then there's also additionally security measures that can be taken with smart door locks. And then the ability to understand, who's the nearest security guard if a certain container is indicating that it's being tampered with or it's being moved. So you're bringing all of these components of data layers and location, and then also the sensing technology to be able to notify the relevant parties as to what issues are happening to that cargo is very important. Leading to this dashboard, this is just an example of some of the things we can do with a smart container technology, not only from a security perspective, but also the handling of the cargo. If it's sensitive goods like pharmaceuticals or produce, it might be sensitive to temperature changes or humidity changes. The ability to set thresholds if it crosses a certain point to notify parties that maybe the reefer isn't plugged in or some action can be taken to avoid the damage of the goods. That's always the best case scenario, is to avoid. But if you can't avoid, at least you're going to have the ability to identify who had custody of the goods and attribute back to the moment that issue happened. Now you'll see here these circles represent shock to the container, and it makes sense that the greatest shock points are going to be when it's onloaded and offloaded from the ship. That's another point of potential damage. And so what we're finding is that a lot of insurance companies are coming to our organization and saying, we would love to adopt this kind of technology for our customers and offer them benefits on the insurance side, whether it's a reduced premium or a higher level of coverage, if you have some of these technologies